physics such as fundamental concepts, X-radiation, the X-ray machine in itself and all of the parts of it. Again, production of X-radiation and then the interactions. Here are your objectives. All right, so the purpose of this is to, first we're just gonna take a quick look at something that you guys already know, and that's about molecules and atoms. Okay, so we're gonna talk about the fundamental concepts of atomic and molecular structure. You are going to be able to define and characterize the X radiation. We're going to talk about the X-ray machine, and we're going to describe in detail how X-rays are produced. So just a review, you guys should already know this. The atomic structure, this is an atom that consists of two parts. It has the central nucleus and then the orbiting electrons. Electrons are tiny negatively charged particles that have very little mass, and they travel in well-defined paths known as orbits or shells. All right, so this should all be a review. All right, what is ionization? This is the production of ions and the process of converting an atom into an ion. All right, radiation, you guys already should know what that is. Radioactivity is the process by which certain unstable atoms or elements undergo spontaneous disintegration, and in that effort, they attain a more balanced nuclear state. Ionizing radiation is radiation that is capable of producing ions by removing or adding an electron to the electron or the atom. The particulate radiation, this is tiny particles of matter that possess mass and travel in straight lines and high speeds. So all of these different terms, you guys should just make note cards and understand your terms, okay? Electromagnetic radiation, this is, we're talking about specifically wavelength energy and how those wavelengths travel through space and matter, what they consist of. And this is on your electromagnetic spectrum over here. Electromagnetic radiations are believed to move through space as both a particle and a wave. Therefore, there are two different concepts, the particle concept and the wave concept, and you have to understand both of those. So you have your particle concept, which characterizes electromagnetic radiation as discrete bundles of energy, and this is called photons. We're going to talk about it as photons. The particle concept has no mass or weight. They travel at the speed of light and they move through space in a straight line. All right, the second concept is the wave concept, and this characterizes electromagnetic radiations as waves and focuses on properties of velocity, wavelength, and frequency. And within this chapter, we're going to be talking a lot about velocity, wavelength, and frequency, so you need to understand these. Velocity is the speed of the wave. Your wavelength is the distance between the crest of one wave and the crest of a next wave. So let me see. Okay, so it's basically the distance between these two crests. Okay. The frequency is the number of wavelengths that pass between a given point at a certain amount of time. All right, so you really need to know these concepts here. All right, does anybody have any questions about that? Again, that was kind of a review. I think everyone already knows about atoms and electrons and everything. Anybody have any questions? No? Okay, a little more review is the X-ray machine. So we have the component parts, we have the X-ray tube, and then you have your X-ray generating apparatus. You guys already know about your component parts, which is the control panel, which is what's on the wall. So that's housing the KVP, the MA, the exposure time, all of that different stuff. And that's also where you press the button to take the radiograph. Your extension arm is number 2. That just allows you to move the tube head. And then the tube head obviously is number 3, and that is where your PID is. Okay, so your control panel, you guys already know this. It has your on-off switch, your indicator light, the controlling devices, and obviously it has to be plugged into an electrical outlet. There's your control panel. Okay, extension arm that suspends the X-ray tube head. It allows us to move and position the tube head. And it also houses all of the wires that extend from the tube head all the way to the control panel. All right, here is the tube head, and we're going to get into detail about what is inside of the tube head. All right, so what is your tube head? That is the tightly sealed heavy metal housing, okay? And that is containing your X-ray tube that essentially produces dental X-rays, okay? And the reason that it's metal is because we don't want X-rays escaping from the tube head. All right, it surrounds the X-ray tube and transformers. It protects everything, and it also helps to ground all of the high voltage components within the tube head. Also, you have your insulating oil, and this is going to also surround the X-ray tube and transformers, and it prevents from overheating or sparking. All right, you also have what's called a tube head seal, and the seal is going to permit exit of X-rays from the tube head. It also seals the oil and it filters the X-ray beam. We also have an X-ray tube or glass vacuum tube, and that is the heart of the generating system. And then within the tube head, there are also what we call transformers, and these different types of transformers alter the voltage of the incoming electricity. All right, here is an aluminum disc. And these help to filter out non-penetrating longer wavelength X-rays. We also have a lead collimator. This helps to restrict the size of the X-ray beam. And then your position indicating device, also known as your PID, helps to aim and shape the beam of the X-ray. All right, here is your tube head. We're going to talk about all these components within the tube head. All right, so if we look back at this picture, you can see this portion here is your position indicating device. That's your PID, okay? And then within this, in the center here, is what we're going to get into now is the glass vacuum tube. All right, so that is that center portion right there. That's your glass vacuum tube. Within the glass vacuum tube, you have two parts on either side called the cathode and the anode. All right, so this is essentially a component that's within the tube head. All right. All right, so your glass vacuum tube is going to measure several inches long and about 1 inch in diameter. Again, this has your leaded glass housing, your cathode, and your anode. All right, leaded glass housing. The purpose of this is to prevent X-rays from escaping in all directions. Okay, we want our X-ray beam to be one path. All right, you need that central ray. Okay, so we don't want X-rays coming out and escaping in all different directions. There is one area of a glass window that permits the X-ray beam to exit from the tube, and then it helps to direct the beam towards the aluminum disc, the lead collimator, and the PID, which we talked about a couple slides ago. All right, so these all work to constrict the beam and everything, but first it's coming from this glass window or housing, okay?
Is the glass window the space that you point out previously?
This is all part of this section here in the middle. Okay. This
yeah.
glass vacuum tube is located within the tube head.
Okay.
All right, so here's your glass vacuum tube. This is the heart of the tube head. This is where X-rays are produced. It is going to give electrons an unobstructed path inside the tube. Okay. So this is basically just a blown up picture of this portion that I circled here. All right, so now we're going to talk about the portions of the glass tube. All right, so I told you there's a cathode, there's an anode. Okay, so the cathode is negative. The anode is positive. All right, you need to know that. So we have our cathode, that's the negative electron. And this consists of a tungsten wire filament within a cup-shaped holder made of what's called molybdenum. And this is called the focusing cup. All right, and the reason that we use tungsten is because it has a high melting point and high atomic number. I bolded this portion right here because you are going to need to know that. All right, so if I ask you why is tungsten used, you need to tell me because it has a high melting point and a high atomic number. All right, the cathode also produces electrons necessary to generate X-rays. All right, we have a source of free electrons. This is the tungsten filament that produces electrons when it's heated. And then you have your molybdenum cup, which focuses electrons into a narrow beam and directs the beam towards the tungsten target, which is on the opposite side on the anode. All right, hold on. Okay. All right, so again, this is your glass vacuum tube. You have your cathode on the left-hand side that's negatively charged. The anode is positively charged. Then you have your filament, and it's aiming all of these electrons towards the tungsten target. Okay. All right, thermionic emission. This is when you turn the unit on, it allows this low voltage current to flow through the filament. Okay, and this is controlled by MA or milliamperage. All right, so the filament will heat up and then causing the electrons to heat up. As those electrons heat up and boil, they vaporize off, which causes this thermionic emission. Okay, so thermionic emission is essentially the boiling off of electrons. All right, and when you get that boiling off, it forms an electron cloud. All right, so I put this little note on the bottom here. It says when you increase your MA, which is also known as your milliamperage, you are also going to increase the number of electrons, which is in turn going to increase heat. All right, so when you increase your MA, you're going to increase the number of electrons. More electrons is going to cause more heat. Okay, here's a picture of thermionic emission. You get your electrons boiling off and forming this cloud. Okay, so that was about the cathode, which is what, negative or positive?
Negative.
Negative.
Good. Okay, so now your anode, this is positive electrode. All right, your anode consists of a wafer-thin tungsten plate, also known as the tungsten target. You can call it either or, tungsten plate or tungsten target. And this target is embedded in a solid copper block. And the reason it's in copper is because copper is a good conductor. All right, your anode is going to convert electrons into X-ray photons. So the tungsten target serves as a focal spot and converts these electrons into what we need, X-ray photons, right? So all of those electrons coming over from the cathode, they're entering now the anode, and they have to be converted. We can't use electrons for radiographs. We need to convert the electrons to photons to be able to visibly see. The copper block functions to help dissipate the heat away from the tungsten target. You always want to have a small focal spot to decrease penumbra for a sharper image. We talked about this last week. Make sure you know that. Hopefully you knew it today for your quiz. All right, also, I just want you to know that it's not written on here, so you need to write this in. The purpose of the copper stem is used with air or oil immersion, and it's used to absorb heat energy. Did everybody get that?
Can you repeat it, please?
Sure. The purpose of your copper stem used with air or oil immersion is to absorb heat energy. Okay, so we're trying to help get rid of some of this heat. Okay, so here it's showing how the electrons are being converted to the electrons are being converted to photons. All right, so again, you started at the cathode, okay? That was negative. Electrons are coming from the cathode, so therefore it has to be negative because electrons have a what type of charge?
Negative.
Negative. Good. Okay, so we have a negative cathode that's giving off negative electrons. All right, it's going through that electron stream and it's going towards that target, tungsten target, okay? Once it's in the anode, what happens to those electrons?
They became photons.
Photons, yes, they become photons, good. All right, some important concepts that you need to know. Amperage. This is the measurement of the number, this part's important, of electrons moving through a conductor. All right, so when we talk about MA, this talks about the number, okay? Then you have volts, which is a measurement of electrical force that causes the electrons to move from a negative pole to a positive one. All right, it's coming from the cathode, which is negative, and it's moving to the anode, which is positive. Again, your MA or your milliamperage, this is the filament current that determines the number of electrons. Okay, so anything that has to do with amperage, milliamperage is also known as MA. This is the number of electrons. It does not have to do with the quality of the electrons. It has to do with the number of electrons. All right, your kVp or your kilovolts, this is the tube current that controls the force that propels the electrons. kVp has to do with quality. All right, you need to write that in. kVp has to do with the quality, and MA has to do with the quantity.
Okay.
Anybody need me to repeat that?
Yes, please.
Okay, MA or milliamperage has to do with the number or the quantity of electrons, and your kVp or your kilovoltage has to do with the quality of the electrons. Okay, exposure time is the amount of time X-rays are being produced. And then your photons, we talked about that, that's bundles of energy, and it creates X-rays. What do photons originate as? Anybody?
Can you repeat it?
Yep. What do photons originate as? What are photons before they're photons?
Electrons.
Electrons.
Wow.
Very good. Okay, so some electrical concepts in your generating apparatus. We have circuits, we have transformers, we have electrical currents. Circuits are a path of an electrical current. There are two electrical circuits that are used in the production of X-rays. You have a low voltage circuit and a high voltage circuit. Okay. And you do need to know those numbers that go with low and high.
Okay.
The circuit is a path of electrical current. You have a filament circuit, which is your low voltage circuit. This only uses 3 to 5 volts. And your low voltage circuit is going to regulate the flow of electrical current to the filament. And this is controlled by your MA. What does MA have to do with? Quality or quantity?
Quantity.
Quantity.
Good.
About
Your high voltage circuit uses 65,000 to 100,000 volts. And this provides high voltage required to generate X-rays. And this is controlled by the kVp setting. What does kVp have to do with? Quantity or quality?
Quality.
Quality, good. And in the US, voltage is normally about 110 volts. All right, electricity is energy used to make X-rays. Obviously, you know what that is. Okay, you need electricity. Your unit has to be plugged in. You need electricity to make X-rays. If your unit is not on, you are not going to get an X-ray. All right, electrical current. This is the flow of electrons through a conductor, always from negative to positive. Okay, so the cathode is negative, the anode is positive. They travel from the cathode to the anode. You always start at a negative area because you have what in that cathode?
electrons.
Electrons. And electrons are what? Negative or positive?
Negative.
Negative. Good. All right. We have a direct current or a DC. This is used in X-rays when electrons flow in one direction through a conductor. The alternating current is when electrons flow in two opposite directions, and this alternates between positive and negative. And then we have something called rectification, and this is the conversion of alternating current to direct current. And this actually happens naturally within your X-ray tube head. Okay, amperage, I talked about this. This is the measurement of the number of electrons. All right, so your electrical current is measured in amperes or milliamperes or MA, whatever you want to call it. I usually say MA. Okay, so this has to do with the number or the quantity. Voltage is the measurement of electrical force that causes electrons to move from a negative pole to a positive pole. And your voltage is measured in either volts or kilovolts. Okay, you have an ampere, which is a unit of measure used to describe the number of electrons. Again, amperage, MA, has to do with number, and it has to do with the current flowing from the cathode filament to the anode. You always start at the cathode, you're always starting negatively, okay? Milliamperage, this just tells you 1 out of 100 or 1,000. You don't have to know that part, but I do want you to know this second bullet here that says in dental radiography, milliamperage or MA ranges from 7 to 15. Okay, If you exceed this, you are going to produce excessive heat. Why are you going to produce excessive heat? What happens when you increase MA? What is also increasing?
The electrons. The
number of electrons. Very good. Okay, so when you increase number of electrons, you're going to increase your MA, so you're going to get a ton of heat. Okay, so you don't want to exceed 15. A lot of these machines, I will say, especially digital, 99% of these machines are already set when you turn them on. Sometimes they have to be altered depending on the patient. If you have a child, you might have to, lower it a little bit, or adult. We're going to get more into that in a couple weeks, but for the most part, they're automatically set, and you will probably never see a machine. I don't even see them at 15. I mean, they're usually at like 8 or 9. Okay. Okay, again, amperage has to do with the amount or the number of electrons passing through the cathode filament. Okay, remember, electrons don't pass through the anode because once they get to the anode, what are they?
Photons.
Photons. Okay.
Photons. Okay.
Good. So increasing your amperage is going to result in an increase in number of electrons traveling from the cathode to the anode and production of an increased number of X-rays. And what else is going to increase?
Can you repeat, please, the question?
Yep. When you increase the number of electrons
the heat
and you increase the MA, what else increases?
The heat also.
Heat. Very good. Okay. All right, so milliamperage regulates the temperature or the heat of the cathode filament. A higher milliamperage setting increases the temperature. It's going to increase the number of electrons. It's going to increase the number of X-rays emitted from the tube. Does that make sense, everybody?
Yes.
Okay.
Yes.
All right, so here we are, X-ray photons. Okay, so this is the current coming in controlled by the MA. Okay, it's coming in at the cathode. All right, so voltage. This is a unit of measurement used to describe potential that drives the electrical current through the circuit. Your kilovoltage, which is usually around 1,000 volts. In dentistry, we usually have our kVp set between 65 and 100. You'll never really see it lower than that, and you'll never definitely see it higher than that. Okay, so you do need to know that it's usually around 65 to 100. And this is your kVp, kilovoltage, kVp. I know this is sloppy, sorry. All right, so when you increase your kilovoltage, the speed of electrons is going to increase. So with that happening, the electrons are going to strike the target with a greater force and a greater energy. Okay, again, what does kilovoltage have to do with?
The quality.
Quality. Yes, good. All right, so X-ray beam quality is determined by the kilovoltage peak. We just talked about that, okay? It also is determined by the exposure time. All right, so a maximum or peak voltage is usually referring to the peak voltage of an alternating current. And again, this has to do with the quality or wavelength and energy of the X-ray beam is controlled by the kilovolt peak, kVp. Okay, exposure time and kilovoltage. So exposure time is an interval of time during which X-rays are being produced. Exposure time is measured in impulses, and you do need to know this, that's why I highlighted it in red, 1/60th of a second. Adjusting the exposure time is necessary when the kilovoltage peak is increased. If you're going to increase your kVp, you have to do something with that exposure time. Otherwise, you're going to end up with a very dark image. Again, we will talk about that more in a couple weeks, but you cannot just increase one thing and not adjust something else, okay? All right, so kilovoltage. kVp determines the wavelength, which determines the energy and the penetrating power of radiation. Okay, X-rays with short wavelength have more penetrating power. Okay, X-rays with long wavelength have less penetrating power. The quality, which is controlled by the kVp, is used to describe the mean energy or penetrating ability. All right, so that's the quality. All right, and you need to write this in because this is not on there, so please listen up and write this in. When you increase your voltage, you're going to have a shorter wavelength. With that shorter wavelength, you're going to have increased frequency, which is going to give you more penetrating power. I'll repeat that.
Yeah.
Okay, when you increase your voltage, you're going to have shorter wavelength. With the shorter wavelength, you're going to have increased frequency, which is going to give you more penetrating power. Did everybody get that?
Can you say that one more time?
Just
please?
going to,
I'll repeat it one more time. When you have increased voltage, you're going to have a shorter wavelength. And when you have a shorter wavelength, you're going to have increased frequency. And this is going to give you more penetrating power.
Do we need to have more penetrating power?
Yes.
Okay.
Your goal is to have shorter wavelengths with more penetrating power, which is on here in this section. Okay. You don't want long wavelengths. Okay.
Okay, thank you. Yeah.
So the goal is to have short wavelengths with higher penetrating power. All right, this is showing you the kVp. Again, this is 1/60th of a second. Here are your X-ray photons. So it's just showing that I just took this from the book. The kVp controls the current passing from the cathode to the anode, and it controls the speed of electrons and the quality of the wavelength. All right, so MA and kVp, when you are going to adjust your milliamperage or your MA, you can increase or decrease the number of electrons passing through the cathode filament. When you increase your MA, you're going to increase the number of electrons, which is also going to then increase the number of photons because your electrons are being converted to photons. So this is increasing the quantity. What is this also increasing?
heat.
Heat. Good. All right, and your kVp adjustment, this is going to control the current that's passing from the cathode, which is what, negative or positive?
Negative.
Negative, good. So it's controlling the current passing from the negative cathode to the positive anode. When you increase kVp, you're increasing the speed of electrons, not the amount, but the speed. Again, shorter wavelengths are going to give you more penetrating X-rays. That's what we want, okay? You do not want long wavelengths. And this is affecting the quality. All right. Anybody have any questions so far? Does everybody understand the difference between MA and kVp and how it controls electrons and heat? Is that a yes?
Yes.
Okay.
Yeah.
Yes.
All right, so we're gonna now get into transformers. All right, so transformers are a device that are used to either increase or decrease the voltage within the electrical circuit. We have 3 types of transformers. You have a step-down transformer, a step-up transformer, and then your auto transformer. And these are pretty self-explanatory. So the step-down transformer is used to decrease the voltage from the incoming 110 or 220 line voltage to the 3 to 5 volts, which is used for the filament circuit. Okay, it has more wire coils in the primary coil than in the secondary coil. So it just, you know, don't make this into something that needs to be totally confusing. Your step-down transformer is going to decrease voltage. Okay, your step-up transformer is used to increase incoming voltage to that 65 to 100,000. So there are more wire coils in the secondary coil than in the primary. All right, and the auto transformer corrects minor fluctuations within the current, and it's basically just compensating this minor fluctuations. Okay, so again, don't make those transformers into something that they need to be, like, you know, they're very, I mean, you read what they are and it basically tells you what happens. So don't stress about the transformers. Okay, here's your transformers. Okay, so now we're going to talk about production of X-radiation, for production of dental X-rays and the types of X-rays produced and more definitions. Okay, so you guys need to know these next couple slides that talk about the production of dental X-rays. It step by step tells you what happens when you go out and press that button. Okay, so electricity from the wall outlet supplies the power to generate X-rays. This is controlled by your MA. What does MA control?
Quantity.
Quantity.
Quantity of what?
Electrons.
Electrons, good. Okay, the electrical current enters the control panel and travels to the tube head via the extension arm. Does that make sense to everybody? So you have an electrical current as soon as you hit that button from your control panel that's traveling through those wires that are within the extension arm. The current is directed to the filament circuit and the step-down transformer within the tube head. Again, your step-down transformer reduces the voltage. The filament circuit uses 3 to 5 volts to heat the tungsten filament, and that is within the cathode. Okay, your cathode has what type of charge?
Negative.
Negative. All right, at this point, you have heated up your tungsten filament, okay? At this point, thermionic emission is going to occur. Thermionic emission is what? Boiling off of
Electrons.
electrons. Good. Okay, so thermionic emission is occurring. Electrons are being released. You're getting the boiling off of electrons. You're going to get that electron cloud. Okay, so your electrons are staying within that electron cloud until the high voltage circuit is activated. Okay. When you press that exposure button, the high voltage circuit is activated. At this point, the molybdenum cup in the cathode directs the electrons to the tungsten target, which is located in what type of anode?
Positive or neutral?
Positive. Yep. When electrons strike the tungsten target, less than 1% of that kinetic energy is converted to X-rays. The remaining is 99% lost as heat. You are going to see this, I promise you, on every single quiz, on midterm exam, final exam, you name it, it's going to be on there. And every year I have people say, I never saw that before. So I don't know what number slide this is, but please start it. Only 1% of that energy is turning into X-rays. Everything else is lost as heat. Okay, 99% is lost as heat. Okay, small number of X-rays are able to exit the tube head through your glass window. Okay, the glass window again has your cathode and your anode. X-rays then travel through that unleaded glass window. the tube head seal, and the aluminum disc, which we talked about. The size of that X-ray beam is being restricted by the lead collimator. And the X-ray beam exits the tube head at the opening of the PID. Okay, these 3 slides, you have to know this. Okay, it's not, magic does not happen when you press that button as much as we wish it did. There is things that actually happen within that tube head, and you guys have to know them. Okay, so these 3 slides lay out exactly what happened. All right, please know that, where was it? Here, okay, in this section here. When you press that exposure button, what is happening? The first thing, the high voltage circuit is being activated. Okay, so that button, when you hit it outside, when it beeps, that's the high voltage circuit is being activated at that point. Okay. Anybody have any questions? Is everybody with me? Because I know this is hard to think about, okay, because you can't really see any of this stuff happening. All right, so X-rays differ in energy and wavelength. What type of wavelength do we want?
Short.
Short wavelength, because what type of penetrating power does short wavelengths have?
High.
Okay, good. All right, so this happens through 2 mechanisms, general radiation and characteristic radiation. All right, your general radiation is many electrons that interact with each other in the tungsten atoms, and they undergo not one, but many interactions within that target. This is where 70% of your X-rays are produced. All right, the sudden stopping of high-speed electrons when they hit that tungsten target is called breaking radiation, which makes sense, okay? Breaking radiation, it's that sudden stop of those electrons when they hit the tungsten target. And this is produced when an electron hits the nucleus of the tungsten atom or passes very closely. All right, so that is general radiation. Next, you have characteristic radiation. And this is produced when you have a high-speed electron that dislodges from the inner shell of the electron, and the tungsten atom causes ionization. Okay, this usually happens at KVP with 70 and above. And what happens is the remaining electrons then have to rearrange and fill in the vacancy, which I'm sure you guys all remember from chemistry, which you probably wanted to forget, but here we are. All right, so this is your characteristic radiation. It's showing that electron that's being ejected near the nucleus, and then your electrons have to now rearrange and fill in that vacant hole. Okay, so types of X-ray radiation, you have primary radiation and we have secondary radiation. Your primary radiation is the penetrating X-ray beam that is produced at the target of the anode, and it exits through a port or a window of the tube head. All right, secondary radiation is X-radiation created when the primary beam interacts with matter. So in our case, we're talking about the head, the bone, the teeth, and it changes the direction. So this radiation has longer wavelengths, low frequency, much lower than primary radiation. And again, we talked about this a couple of slides ago. The high atomic number has high energy waves, and a low atomic number has lower energy waves. All right, scatter radiation is a type of secondary radiation that results when an X-ray that has been deflected from its path interacts with matter. Okay, you do not want to have scatter radiation. Okay, there are 2 types of scatter radiation called coherent and Compton. Again, this is showing the secondary radiation. All right, so Compton and coherent. I'm just going to go through these pictures. These are taken directly from the book. All right, so when an X-ray photon passes through the atom unchanged and leaves the atom unchanged, okay, so there was no interaction at that point. The photons are responsible for producing densities on the film, and it makes dental radiography possible. We're going to talk more about density, contrast, all of that. Okay, so photoelectron effect, this is 30%. So an X-ray photon is completely absorbed within matter of the tissues of the patient, okay? So when it absorbs, this is the total transfer of energy from a photon to the atoms of matter, like I talked about, head, teeth, all of that. Photoelectric effect is an X-ray photon that collides with a tightly bound inner shell electron. And this is going to give up all its energy and it's going to eject from the electron and the orbit. Okay, then you have your Compton scatter, which is 62%. And this is when the X-ray photon is deflected from its path during its passage through matter. Basically, it's colliding with loosely bound outer shell electron and it's giving up part of its energy to eject from that orbit. So the X-ray photon is losing energy and it continues in a different direction at a low energy level. So any electron that's ejected from its shell is termed a Compton electron. So X-ray photon loses energy and it continues in a different direction. Okay, again, the Compton electron is any electron that's ejected from its path. And then coherent scatter is 8%, and this is the X-ray photon that has its path altered by matter. So at this point, there is no change in the atom. The X-ray photon is scattered radiation is being produced, but there's been no loss of energy or no ionization. So this is completely different than Compton. Okay. Does anybody have any questions about that? I mean, basically, you're just going to have to, make note cards or something and just remember those are the two different types of scatter radiation. Anybody have any questions? Are you guys still on?
Yeah.
Yes.
Okay.
Yes.
Oh, yeah.
Okay. All right. So we're almost done. I know this has been a long chapter. All right. So differential absorption. This is the rate or the amount of radiation that's being absorbed by different tissues depending on the structure's density. So differential absorption is what gives radiographs those varying shades of black and gray, or radiolucent versus radiopaque, which we talked about in the first week. A material with low density is going to be radiolucent since the radiation is able to pass through those structures. So in a radiograph, you see air spaces are very dark or radiolucent because X-rays were able to pass through. Okay. A material with high density is going to be more radiopaque because X-rays are not able to pass through as freely. So therefore, it's more of, those whites or grays. All right, so a couple questions for the end of the chapter. Which of the following is used to increase voltage in the high voltage circuit?
Step up.
Step up transformer, A, very good. All right, number 2, which of the following is location where X-rays are produced?
C.
The
It's B, yep. Positive anode, very good. All right, let's see, the next one. Identify the source of electrons used for the production of X-rays.
Is that B?
It's the tungsten, it's the
Filament.
tungsten filament.
Okay. Okay.
Yep, D. All right, number 4, which of the following does not occur when the high voltage circuit is activated?
B. It's not cathode.
Is it
A does not occur.
Does not occur, so it's C.
Okay.
X-rays travel from the filament to the target.
Okay.
So electrons are being produced, therefore heat is being produced,
Mhm.
okay? All right, number 5, increasing the kVp of an X-ray machine is going to increase what else?
The number and energy of the X-ray photons.
Not the number. What does the number
B.
have to do with?
B.
Well, that was the quality. Hold on, the quality. So me.
kVp has to do with the quality. So what would the answer be in this one?
D. No.
It's the average or the
B.
mean wavelength of the photons.
I
Okay,
said B.
B. Yep. Okay, increasing milliamperage is going to also increase what?
C.
Hmm,
A and C.
Oh.
A and C. Maybe it's
A and C. Number, it's D. The
Oh,
answer is D. So when you
okay.
increase milliamperage, you're increasing the temperature and you're increasing the
The
number
number,
of
okay.
X-rays. Okay. Make sure when you read the question, you read all of the answers before you select one. All right, so here's the answers if you want to write them down so you have them. All right, so here is your homework for the week. I'm going to post it to D2L, but what you're going to do is you're going to be labeling these 2 parts of the tube head. Okay, so you're going to label the tube head, and then you're also going to label this portion, which is, what is this portion called?
Was it the glass? Which one you were looking at?
I'm looking at this one that's on the screen. What is this portion called?
The pit.
The glass.
The glass.
Tube.
Oh my god. So it's, oh my god, I forgot the other part.
Is it glass vacuum tube?
Here we go. That's the fact.
All right, it's the glass window.
The glass window. Oh my god.
Okay. What is this portion over here?
Cathode.
Cathode.
The cathode. Yes. Okay. So I'm going to post this to D2L. You guys are going to be in charge of labeling these 2 parts and make sure that you email them to me before the start of next week's quiz. Just a little clue here. If I'm having you do this as homework, it's most likely going to be on a quiz, right?
Right.
So make sure you know the parts, okay? Make sure you know that this is the glass window that's located within the tube head, okay? It's this portion here.
Yes.
You're just looking at it closer, okay? All right, who has questions from this week? All right, I'm gonna do a review for next week's quiz and then I will let you guys go. Okay, so next week you need to know about the cathode and what are the parts of the cathode. You need to know about the anode and which are the parts of the anode. You need to know about your glass vacuum. You need to know how much is produced as heat and how much is produced as radiograph. You need to understand what happens when you increase the current within the filament.
Can you repeat that, please? Again?
What happens when you increase the current in the filament. Okay, you need to know about quality versus quantity and what those affect. You need to know about your step up and step down transformer. You need to know what thermionic emission is. You need to know what a volt versus a kilovolt and a force, all of those. You need to know your definitions. You need to know what happens when you increase MA or increase KVP. You need to know where X-rays are produced. You need to know how X-rays are produced. You need to know the differences between orbital, characteristic, particulate, and braking radiation. You need to know the difference between coherent, general, characteristic, and leakage radiation. You need to know about your primary, your secondary, your scatter radiation. And you need to understand how all of these parts within the tube head work together to create radiographs and X-rays. Does anybody have any questions?
Yeah, what was the first thing that you said about the cathode and the anode?
You need to know what parts are part of the cathode and what parts are part of the anode.
Okay, thank you.
Mm-hmm. Any other questions? All right, so I will post your homework to D2L and make sure you study. I will tell you guys, this quiz 3 is always seems to be everyone's most difficult quiz, okay? So please do not wait till the last night to study.
When is the homework due?
Before class on Friday,
Okay, thank you.
all right?
Would there be an extra credit or is that the extra credit?
I don't know if I'm doing extra credit this week. I haven't decided.
Okay.
That's the homework, that's not the extra credit.
Yeah, okay.
Extra credit is aside from that, if there will be any, I'm not sure.
Okay.
All right, if you don't have any other questions, I will see you guys next week. Have a good weekend.
You too. Thank you.
Thank you.
Thank
Have a
you.
good weekend.
Thank you. Bye-bye.
Thanks, bye.
Mrs. T,
Yes,
you said we can have like a meeting after class.
yep, as soon as everyone logs off.
All right.
I just had to, I don't know, oh, can you hear me?
Yes,
I don't know if you got my chat.
is that Angela?
Yes.
Hold on here. Oh, about the spelling?
Yes.
Okay,
I spelled it 2 different ways, but I think the second way was the correct one. But I put both of them on there. Same
Okay.
answer, just 2 different. I got confused with the spelling, but I think it's the second one that's spelled right.
okay, I'll take a look at it. All right.
Okay, thank you. Bye.
Mhm.
Have a nice weekend.
You too. All right, Anna, let me pull up. Daisy, are you still here? All right, she must have walked away. Oh, hold on, Iana.
Yes.
All right, Iana, go to that breakout room
Yes, all right.